This is the third formula that will be discussed in the Exponential Applications series. This is exponential decay, and it's similar to exponential growth. The only difference is your operation. In decay, it's going to have a subtraction sign, whereas in the exponential growth, it's going to have an addition sign. So the first thing I like to do is go ahead and count my variables so I can see what I need to keep track of. I have A of t is equal to P times the quantity of 1 minus R raised to the T power. So I highlighted 4 variables, which tells me that I'm looking for at least 3 of them in my word problem, and the 4th one is the one that I'm going to be solving solving. So I've already discussed in other videos what each of the variables represent. So you can just read through that if you need to. In this first word problem, if I had not known that I was working with exponential decay, what I want to look for are keywords. So decay, decrease, depreciate. So something that's going down or losing value, eliminate. Those are the type of words that I'm looking for to tell me that I will be using this specific formula. So Ashley purchased an all-terrain vehicle so that she could join Toby and Selma in off-road recreational activities. When she bought the vehicle, the value was $7,500. Since then, it has depreciated by 3.2% every year. What will it be worth in 4 years? So this is the second thing I want to do. I want to identify what exactly is it that I'm looking for. So what will it be worth in 4 years? That means that's a future value. So my future value is going to be A of t. That's what I'm looking for. Therefore, I have to be able to locate P, R, and T within my word problem. So I saw 7,500. That was the value when she initially bought the vehicle. So initial principal, the present, that is going to be 7,500. That's represented by P. Since then, it has depreciated by 3.2%. Well, that's going to be a rate. So I want to put that in decimal form, which is 0.032. And what will it be worth in 4 years? So the time is 4. I look over at my actual formula and I notice where each one of the variables are positioned, and that's where I'm going to put this information that I just pulled out. A of t is the one that I'm trying to find, so I'm just going to go ahead and leave it as A of t. P, I notice, is now 7,500. That's multiplied times the quantity of 1 minus the rate, which is 0.032, and that's raised to the 4th power. If I ever have a variable on the side by itself, all I have to do is go to the calculator and type in exactly what I see on the opposite side of the equal sign. So that's what I'm going to do. I'm going to go to our calculator, and I've already typed it in for the sake of time, and it is $6,585.10 because we're talking money. So we're just going to round it to the nearest hundreds. So let's go back to, oops, sorry, I lost my screen. And we're going to write A of t is equal to, since we're talking money, $6,585.10. Well, if you've been looking at these videos, you realize that I am taking the same scenario and I am trying to find every one of the variables that's shown. So for the next one, I want to find P. Well, I just said A of t is 6,585. Yeah, $6,585.10. And also, just to the side, I always just keep track of my data. You don't have to do this. I just do that. All right, now what I want to do, if I see that the variable is on the same side as the exponent, I want to go ahead and simplify that exponent. So I'm going to take this 6585.10, go ahead and bring that down. And now I'm going to take my base and raise it to that exponent and simplify it. So let's go ahead and go to our calculator and put in parentheses, 1 minus 0.032, parentheses, and I want to raise that to the fourth power. And when I do that, I notice that I have 0.8780. I'm only going to go 4 places after the decimal. So let's go ahead and write that down. 0.8780, but I had a P above. So I want to make sure that I divide both sides by what's stopping P from being by itself, which is that 0.8780. What I do to one side, I have to do to the other. And then I'm just going to put my variable on the left-hand side. And in my calculator, go back and I'm going to type in 6585.10, sorry, 0.10. And I'm going to divide it by the entire decimal that was above. So I'm going to go to second negative. That will copy this entire decimal so I don't have to type all of that in. Hit equal. And when I round that, it's going to be 7,500 because the 9 after the decimal will add 1 to the number in front. So that's going to make it 7500. But again, we already knew that because I'm using the exact same problem. I'm just showing you how to find different variables. So 7,500 is what is P. P was, if I go back to my original problem, it was what the initial value was. So since we're talking money, let's go ahead and make that dollars. That's P. Okay, so now we're just going to keep building the same scenario. This time we want to find R. And we just said over here that P was 7,500. So I can go ahead and put that in my formula where P would normally be located, which is after the equal sign. So 7,500. And when my problem looks like this, I want to separate my exponent. So whatever is stopping my exponent from being by itself, or isolate is a better term. Whatever is stopping it from being by itself is what I want to get rid of. So there's a 7,500 in front. So I want to divide both sides by that 7,500. So I can get rid of that and isolate my exponent. And now I'm going to go back to my calculator and put in 6585.10. This time I'm dividing it by 7,500. And when I do that, I get that same 0.8780 that I got a few minutes ago. So we're just going to go ahead and write that down. And that is 0.8780. I'm going to set that equal to what's left over on this side, which is 1 minus R raised to the fourth power. What I'm trying to do now is get rid of this exponent. So the inverse is to take the fourth root. So once I take the fourth root of both sides, I'm going to get rid of that power over here. That was the whole purpose of doing it. And then in my calculator, I'm going to type 4 math, and then I'm going to go down to number 5. And now I can type in 0.8780. And I'm going to take that to 4 decimal places after, which means I'm going to have to round it to 0.9680. Let's go ahead and do that. 0.9680. And then what's left over on this side is 1 minus R. And what I want to do is get R by itself. So that means I'm going to have to add R on both sides. And I'm going to subtract 0.9680 on both sides. When I do that, I see that R, and I'm getting kind of close here. So R is going to equal, now I go to my calculator and I'm going to do 1 minus, and in this case, I'm just going to take second and negative, which is going to copy the answer that I just got. So it's 0.032. So R is 0.032. But in my answer, I want to convert it back to a percent. So this is really 3.2%. And again, remember, now you're going the opposite direction. So what you're going to do is take your decimal, move it over 2 places, and then put a percent sign. That's how you convert it back to a percent. So now let's go to D, which is where we're finding T. Okay, we already have it set up. The only thing we need to do now is go ahead and get rid of what's stopping the exponent from being by itself, which is this 7,500 again. We've already put this in a calculator before, so we're going to end up with that same answer, 0.8780. And on this side, we want to go ahead and simplify that. So, well, I'll just do it for your sake. So it's going to be 1 minus 0.032, which is 0.968. And we're going to take that and we're going to raise it to the T power. Once you do this part, you can just rewrite it as a log. So log is going to have the same base as your exponent. So 0.968 of 0.8780 is going to give me my T. So T is equal to, go to the calculator, and I've shown you this multiple times. You want to go to math, alpha, math, and now you can put in your base 0.968 of 0.8780. If you don't have that option, that means you're going to have to use the change base formula, which means, hold on, I'll show you in a minute. Let's just go ahead and write our answer here. That's 4. So T is going to be 4, but again, we already knew that. We're just building off of what if they had asked for T. So for those people who don't have the option to do math, alpha math, what you would do is what's called the change of base formula, where you would draw your line here, and you would literally have to put log, let's go here. You would have to use this button, log, and then the big number, 0.8780 in parentheses, and then divided by another log, and now your base, 0.968. And you'll see it's the exact same number. You just have to do more steps if you don't have the option under math that you scroll down to get to A. That's what you'll have to do. Okay, this is the last example. Melania and Samir decided to test how long caffeine from soda would stay in a person's system. Sador decided to help them out by participating in their experiment. He consumed 1,065 milliliters of soda. After monitoring him for 5 hours, it was determined that approximately 562 milliliters of caffeine remained in his system. They wanted to calculate the rate per hour at which the caffeine was eliminated from his bloodstream. So again, you're looking for keywords. So this is telling me eliminated, that he's losing something or something's being lost. So therefore, I want to use the exponential decay formula. I want to go through and I want to determine what is it that I'm looking for. They wanted to calculate the rate per hour. The key word here is rate. That's what I'm looking for. So I'm going to go ahead and put a question mark by rate, and everything else should actually be in the word problem. So let's start where we see our first number. He consumed 1,065 milliliters of soda. Okay, maybe that's not enough to tell you whether or not that's a present value or a future. So let's read on. After monitoring him for 5 hours, so we know the time is 5, it was determined that approximately 562 milliliters of caffeine remained. So that tells me that's the future value. So 562 is A of T. So therefore 1,065 is my present value, or my P. Now, what I want you to pay attention to, some of you automatically think A of T should be the bigger number. That is not necessarily true, as you see in this case. It's not the bigger number. So now I just take this information based off of where the variables are located in the formula. That's where I'm going to place my number. So A of T is 562. That's placed before my equal sign. P is 1,065. and 65, and that's placed after my equal sign, times the quantity of 1 minus, I don't know my rate. That's what I'm trying to find out. T is to the 5th power. What I want to do is isolate my exponent. So what's stopping it from being by itself is this 1065. So I have to not only divide it on that side, I also have to divide it on the other side. Now I'm going to go to my calculator and I'm just going to go ahead and do the math. To get out of the screen, I go to second mode. I can clear that out so I'm not confused. And I have 562 divided by 1065. And that leaves me with 0.527, and I'm going to round that to 7. So 0.5277 on this side. And then what's left on the other side is the quantity of 1 minus r raised to the 5th power. So what I'm trying to do now is get rid of this exponent. So to do that, I have to take the 5th root. What I do to one side, I do to the other. So the 5th root will allow that power to go away. I go back to my calculator. I type in 5 math. I go down to the number 5. That allows me to get the 5th root. I can go ahead and type my whole answer. I can copy it by doing second negative. And then once I press equal, that's going to give me 0.8799, which when I round it is 0.8800. So that's what I'm going to work with now. 0.8, I don't really have to put the 0, 0.8800, but I'm just going to, for consistency purposes, 1 minus r. And again, I'm trying to get r by itself. It's currently a negative r, so I want to put it on the other side as a positive r. And now I want to take the 0.88 and I want to take the inverse, which is subtracting it. So I'm going to subtract that on both sides. That goes away. And then on that side, that goes away. I'm left with r is equal to, and now I go to my calculator and I type in 1 minus, again, I can do second negative, which is going to copy this entire decimal that's already in the calculator, and it's going to be 0.12. So that represents my rate, 0.12. When I get my answer, I have to convert that back to a percent. So R is actually 12%. I have shown you in other videos how that you can go through and use your Y equals button, especially like in cases like here, you could have put Y equals 0.968T, and then under your Y in your table, look for 0.8780, or you could have put Y equals what I just circled there in your table, go to Y, and it should equal this. So I've shown you in other videos how to do it if you want to actually go back and review those. Okay, thank you for your time. Subscribe and like the video.